So today we're going to talk about how to use Terraform to integrate Azure into your hybrid multi-cloud strategy. Let's start with a quick survey. How many of you are familiar with Terraform? Great, so almost half the room. And how many of you use or plan to use Terraform with Azure? Okay, so great. So you're in the right talk. So we've got half the room not familiar with Terraform. So let's quickly start with, before this, let me just talk a little bit about what I do and and introduce my teammates here for the session. I'm the principal PM for Azure DevX. My name is Arun Chandrasekhar. My core focus is to integrate open source software to Azure, things such as Terraform, Ansible, Jenkins, and so on. To my left is Damien Caro, who's a software engineering manager in CSE, which is customer-facing solutions that we want to evangelize, as well as you can talk about.
So we work with customers on their adoption and their blockers with onboarding to Azure.
And then I have Tom Harvey from HashiCorp, who's one of the primary Terraform engineers working with us on the Azure RM provider. So today we're going to talk about things from four different perspectives. The first perspective is about what does it mean to embrace infrastructure as code, where we'll talk a little bit and give an overview of everything going on around how do you get into the Terraform context, how do you switch from what you're doing right now into Terraform. And then Tom will go through some, more details on how to provision infrastructure using Terraform. And finally, as developers, how do you deploy applications on top of this infrastructure that you have created? And we'll talk about a whole bunch of futures in the wrap-up. So when you talk about embracing infrastructure as code, one of the key things to understand here is Terraform, for those of you who are not familiar, is this notion where, like the term Terraform in the English dictionary is about things like Elon Musk trying to terraform Mars, which is to make Mars look like Earth. So as 85% of enterprises from a recent survey are trying to get into the hybrid data center from their on-premise traditional data centers, they like to have some kind of a uniform way to go about it. So if you look at different clouds, both like on-premise or private clouds such as VMware or Azure or other clouds, each of them have their own way of expressing infrastructure as code. However, if you have a certain set of code infrastructure that you want to express uniformly across everything, then Terraform is a nice open source tool that lets you do that, right? So what's really nice about it, and that's one of the reasons for its success, is it gives you a very nice DSL, which is on top of JSON, so you can effectively go down to JSON if you want, but it's not as verbose as JSON. So this is just an example of what that looks like. And you also get the sort of convenience of having a DSL, which will let you build out higher level abstractions, such as modules, which we'll talk about in a bit. And this particular language that is used across HashiCorp. It's called the HashiCorp configuration language. This is the language that Terraform uses. And think of it as something between, not as verbose as JSON, not over simple like YAML. It's a good balance between the two. And the other thing that's really unique, I mean, it's not unique, but it's very, very, very important to understand from a Terraform perspective, is that not only are you going to build out things within the Azure boundary using the Azure provider, which is the one that most of us are working on, so you can get a whole bunch of core resources, data, apps, and all these things that you see here, and several more things within Azure. But you can also go and use sort of the multitude of third-party providers that you want to use with Azure, either inside Azure, such as Kubernetes, or it could be something outside, like, say, Datadog or Cloudflare, and so on. And there's also a whole set of provisioners that you can use on top of Terraform. So think of Terraform as something that just builds infrastructure and goes away. And then your config management, you could use things like the Chef provisioner or the Ansible provisioner, and things that integrate well for your config management needs. So let's go to a quick overview of what Terraform looks like. And let me just show you. Let me switch to browser. Let's see it. Okay. So the first thing you would like to go to if you want to learn about Terraform is go to terraform.io. And here you can see a whole variety of providers that are supported. There are over like 80 or so providers for every possible chunk of like major cloud, infrastructure software, networking, and so on. So you can start leveraging all of these providers if you use Terraform using the same consistent experience. The provider that we are going to be drilling down in right now is the Azure provider. So if you look at the Azure provider, it has a whole bunch of data sources, which Tom will go into in detail, and resources and so on. So what we're going to do is try and take maybe a simple example usage of what this looks like. And this is just something that's just creating a resource group in Azure. So let's see how we would go about doing this in Visual Studio Code. So how many of you use Visual Studio Code with as your primary editor for scripting? Okay, a few of you. So one of the things that we've done with Terraform is to integrate a couple of extensions. So one of the extensions is a community-provided extension, which is a Terraform extension, which gives you things like linting and color coding and so on that you see here. But there's also the Azure Terraform extension that we have built that lets you integrate deeply with Terraform right in the VS Code environment. So I was facing some networking issues, so we might switch to Damien
go ahead.
in order to do this. But let me just do a quick try here, if it doesn't work on that one. So one of the things that we have when you install the Azure Terraform extension is the ability to do things like initialize, visualize, apply, plan, and push. There's a few things that you can do with Terraform right in the context of your Visual Studio Code. So let me do an init. So what init is doing in this particular context, as you can see here, it's using bash in Cloud Shell. So what you've done is you've taken Cloud Shell, which is the Azure. How many of you are familiar with Cloud Shell? Sorry. Okay, Cloud Shell is just the Azure's browser-based shell for the Azure portal. So you can use the shell in the browser to go and interact with that. What you've done is you've embedded that instance of the browser into your editor, so you don't have to go switch between the browser and here. And one of the nice things that it does is it takes your existing workspace, whatever you have locally, and creates a cloud drive. So what it's doing is effectively taking your local files and syncing it into Azure. Right? So now you've got a bunch of your Terraform files sitting in Azure. And then if we try and do, let's say, a plan, what it's going to do is it's going to basically take what you have here locally. In this case, I have a module, which I'll talk about in a second. And it's going to take, it's going to go and say, OK, these are the kind of things that are going to get created by using this particular module in Azure. So if you can look at the list of things that the module creates, it's actually a crazy amount of things. And I'll show you the sort of visualization of what this looks like. But think of it as a module. As I said, HCL is a language. It is a DSL on top of JSON. So with that, you get this sort of higher level abstractions that you can build called modules. What you get with that is this very simple interface. So let me go back to browser. Let me just take you to let me just do a simple shortcut to get to this. So what you get here is basically a registry which has a bunch of pre-existing set of modules that either we've developed or the community has developed for spinning up specific pieces of infrastructure, right? So in this case, we are looking at the load balancer, which is a particular type of module, and all it's saying is all I need to do is say create a module called load balancer and just give me one required variable. In this case, the required variable would be the location. So all I've done here is define the module and specify the location and nothing else. So with this, what it's doing is actually going and creating all the underlying complexity of the module is completely sort of abstracted away for you for things like IP configuration, public IP, and all those things that you see here are getting created for you from this very simple single sort of sense. So once you try to do a run, which is an apply in this case, it's going to take everything that I just showed you, and basically it's going to say it's going to add 4 things, and it's going to change 0 and destroy 0. There's this thing called the plan, which is already ran, and plan is another very powerful thing as developers for Terraform. So what plan does is basically says, this is my local state of what I want to do, right? And then it's going to compare it with what actually exists in Azure, and it's going to true it up to make sure, okay, is it really going to be in sync? And it's going to say this is the delta between the two that you can see here. So that lets you use infrastructure as code very confidently by doing a whole bunch of sort of quick dev test cycles on your infrastructure as code. So what it's trying to do here is going to spin up all these public IP, backend IP configurations, and so on. So if I say yes, and I go ahead and ask it to create it, it's gone and created a whole bunch of resources, right? It went and created all the resources that that module goes ahead and generates. So let me go back. I just want to show you one other thing. So what we talked about here is just how you use a module within the context of Visual Studio Code to go and quickly apply something into Azure, right? Now, just to show you that this is not just something that's happening in sort of a demo environment, if you go into the actual Cloud Shell, so you can now go into the browser, or you can use your phone, and basically everything that we just created from your Visual Studio Code editor is now available in the cloud. So what that means is you can go and make changes directly in your Cloud Shell environment without needing to worry about whether you're on the Visual Studio Code editor or not. So you can do a whole bunch of, you can mix and match. So let me just show you the environment that we just created. So we had a workspace. Oh, I just put it on the main. Okay. So this is a different user ID. But basically, the cloud drive that you see here would have created the main file and the terraform.tf state file. So the state file is basically a file that is showing your current context of everything that you have, and it's going to show like what is the state that you made changes to in Azure. But however, all this is great. So you can do this with the Cloud Shell, you can do this with your editor. But what if you want to take the same state and share it across multiple people in your team? So let's say this is production state, right? It's not just or a test environment that you want to just share across multiple people in your team. Then you cannot just use your local file state or state in Cloud Drive. So for that, what we have is we have something called the Terraform in the marketplace, which will give you. So basically, it's just a Terraform instance in the marketplace. What this does is does a couple of things. One is it basically lets you share your identity using the managed service identity. So you have a Terraform instance that sits in Azure that you can now use across your DevOps workflows or in your test environments as a shared Terraform instance. And it also lets you use remote state, which Tom will talk about a little bit later. And this gives you the ability to completely not worry about where the Terraform instance is, because the exact same instance, whether you're using the OSS tool, locally you're using the Terraform instance in the marketplace, as well as Terraform Enterprise, which Tom will go into deeper. So these are a few, so that's kind of a high level of overview of everything that Terraform has. So just went all the way to the front, that's interesting. So what you just saw is basically the fact that you can use Terraform in the Visual Studio Code editor. You can use Terraform in your browser-based shell. You can use, you can also as well use Terraform in the marketplace, and there are several like this. You can also use Terraform as its own instance. With that, let me hand it over to Tom, who'll go a bit deeper into how do you make this real. So this is just an overview of what Terraform is, and now we talk about how do you provision infrastructure using Terraform.
So we've been working with Microsoft for the past year or so, and we've been expanding our resource coverage pretty extensively across a wide variety of things in Azure. So from IaaS, the data services, to PaaS, to managed services, across services that are GA, through preview, and we're trying to support services as they launch. So Event Grid, we launched, I think, within a week of launch, which was quite cool. What I'm gonna do is demonstrate can we switch to my, thanks.
7 or 8?
8.
8.
So as Arun said, we've been working pretty extensively on this. We support, there's two types of resources available in Terraform. There's a data source, which allows you to get information about an existing resource. So for example, an Event Hub namespace, which allows you to access any properties on that. We also support resources, so everything from web apps to CDNs to databases to Redis as an example. And each of these comes with a good code sample for how to use it. So yeah, we've been doing a lot with that. What I'm going to demonstrate to you, I have a pre-existing, in fact, let me come back. Ooh. Well, that. One of the most popular resources, or one of the most requested resources we've had recently is AKS, which is the managed Kubernetes offering. I'm going to demonstrate how we can use Kubernetes, how we can use multiple providers in Terraform. So we've already provisioned a Kubernetes cluster in Terraform and a Redis cache in Terraform. And I've got modules for this, so I'm hoping you can all read that. So I've got a couple of modules here. So we create a resource group in Terraform. We then create a public and private SSH key pair for the cluster. We then create a cluster, and I'll dig into these modules in a minute, and a Redis cache. And then we're going to use that information to populate values within the Kubernetes, using the Kubernetes provider. So we support creating a bunch of things within Kubernetes. Yeah. So we have modules here that exist. It basically just makes it easier for us to create and reuse things. So as Arun mentioned, it's possible to source these from different locations. There's the Terraform module registry. You can also source these from a local path, from GitHub, from Bitbucket, or any other VCS repo. Yeah, it's pretty handy. So in my example, Terraform has this concept of a provider, and we're threading through the variables from the AKS cluster. So in this case, we're using the host, username, password, and the certificates to access from the AKS cluster to be able to provision, in this case, a namespace within it. So where Terraform's a command line tool, I can run Terraform plan, and because at this point I have already created an AKS cluster and a Redis cache, it's going to show me there's nothing to do. Now, if I connect to this, to the Redis cache, to the Kubernetes machine rather, and we go to namespaces, you can see right now there's no build namespace. If I go through to my code, let me uncomment this. What this is going to do is create a namespace in Kubernetes based on the values, based on the credentials that exist for the AKS cluster. So if we run Terraform apply, Terraform's going to go ahead and say, hey, I know the current state of the world. I know I haven't created a namespace in Kubernetes, so I need to do that, which is what you can see here. So if we do yes, and then refresh, we now have a build namespace. We can do much the same for where Terraform supports multiple providers, you can chain any providers together. In this case, we can also do the same thing with secrets. So in this case, I'm storing the Redis connection string in Kubernetes. We could also store this in any other product, so with Datadog or with HashiCorp Vault or anything else. So again, I can do Terraform apply. It'll show me that the namespace exists. And so there's just a secret to add. So it goes ahead and does that. So if we switch to the build namespace and then head down to secrets, you can see the Redis secret exists. Cool. One of the other things we can do is to demo scale, is we can show the cluster scaling. So in this case, I have some variables that are set up in the Kubernetes cluster. In this case, is the agent count, which is currently 3. That's a default variable. One of the things I can do is to override that within here. So where it's defaulted, I don't actually need to specify this by default. If I make this 5 and rerun Terraform apply, again, it's going to detect it needs to scale the number of machines from 3 to 5. Which it'll do. while it's doing that, because this takes a little while, if we come to the resource groups, go to the Kubernetes cluster, and then to scale, we can see it's updating, and then it's going from 5, or it's gone from 3 to 5. So I'm just going to let that run because it takes a little while the machines boot. But yeah, that works. So one of the other things you can do, so Terraform knows the state of the world based on a state file, which is where it stores all the values about the things that have been provisioned. So for instance, it knows that the Kubernetes namespace exists. So if I were to remove that from code, it would now try and delete it. Where you're working across teams, you can store that in a backend. So you can store this on your local machine by default. But you can also store it in blob storage or in a bunch of different backends. And these are all fully supported. The nice thing about using a backend is this is encrypted at rest. So in blob storage, for instance, blob storage accounts are now encrypted by default, unless the state is encrypted, which is cool. Cool. Can we switch back to the slides? Cool. So what we just showed you, we've had a pre-existing Redis cache and a Kubernetes cluster. We've used the Kubernetes provider to work across providers in Terraform to be able to provision a namespace and then put that secret, the Redis connection string, within the Kubernetes cluster. Now, the backend in Terraform is a great way of sharing state across teams. For other teams, we have we have an enterprise product as well, which is focused around collaboration and policy and governance, which has things like policy as code. So you can say you're only allowed to deploy in, I don't know, the West US region, or you're only allowed to provision 20 VMs, not 200, in case someone accidentally fat fingers it, which has happened. Cool. So I'm just going to give you a quick demo of Terraform Enterprise, just because. So yeah. All the repositories for this is open source, by the way. We'll have links at the end. So Terraform Enterprise has a private module registry in addition to the public module registry. So for instance, here I have a Kubernetes module and a Kubernetes network, which is accessible in much the same way as the public Terraform registry, but it's private to your organization. I've also got a workspace set up here. So in this case, it's a search API that will, let's open the source code. So in this case, we're going to provision an app service with a couple of slots. So we provision a new resource group here. We then put an app service plan inside of that, and then create a primary, and an app service, sorry, and then create 2 slots. So we create a primary and a secondary slot. And there's a difference between these two, which is the feature flag here, which is feature enabled false and feature enabled true. And we have this active slot resource in Terraform, which allows you to pick which slot is active. So primary or secondary, which means you can do deployments and rolling deployments and things. So if we run, so this is just an ordinary Git repository. It's a private Git repository. It could be public. So in Terraform Enterprise, you can set variables for things. So in this case, the location is West US, and this is a subscription we're using. But I can hit qplan, or I can just do a git push. Terraform Enterprise will then go and do the plan for me. And go, hey, much the same as it was locally, here's the things that I need to do to get it from where we are today to where we need to be. And it goes, we need to confirm it. So much the same as a pull request or something, you can come in here and approve and put comments for why you're doing something. So, looks good to me. Confirm and apply, and then that'll run it. The nice thing about this is it means no team members need credentials to be able to deploy things, because Terraform Enterprise can do that for you.
So Tom basically talked about how to provision infrastructure as well as how to use it in the enterprise. Another thing that we are just announcing today is that we also have the private Terraform Enterprise available on Azure. So what you could do is you could install everything that he showed you as Terraform Enterprise directly on Azure and then use it with all the different providers. So switching gears a little bit, the crux of this is really about infrastructure as code. So when you talk about infrastructure as code, we sort of showed you how the lower layer of this infrastructure works and how you can provision this. However, a lot of developers, and in this case, we showed things like you can chain providers together with, say, things like Redis, Kubernetes, and app service, and you can do zero downtime deployments with app service slots. You can use all the richness of Azure directly against the infrastructure. However, the developers generally have started demanding something a little bit more sophisticated, a true abstraction layer, right? Because while this is cloud agnostic at the core infrastructure layer, you still need to be aware of each cloud's idiosyncrasies as you're writing your Terraform HCL to make sure that the infra as code matches with the cloud. So most people are just using containers, and the platform that they're using in the app layer is generally Kubernetes, right? So most major cloud applications, but it's not just the application platform is just Kubernetes. If you want any kind of abstraction, things like, say, Pivotal's Cloud Foundry, for example, uses terraforming on Azure to basically provision all of Cloud Foundry on Azure, right? And you also have things like HashiCorp's own Nomad platform, which also lets you do orchestration across containers, VMs, what have you. So what this gives you is the ability to shift from the infrastructure layer, which is your infra as code piece, to the app platform layer, and then just work against that and start deploying applications to that. So with that, I'm going to shift, and Damien is going to show you how can we go and start deploying applications as a developer onto this Kubernetes environment that Tom talked about. Let's shift to 7.
Yes, please. Thank you, Arun. So as we mentioned, now we're going to have a focus on an application. And the application we're going to deploy today on this cluster is going to be a voting application. And I have a burning question I want to ask you. So I will, at one point in this demo, I'm going to ask you to participate and vote what is the answer you prefer. But before we get there, let's make sure that the cluster I have is not running anything. So we actually have an empty cluster. So I'm using the kubectl command for that, just to show that there are absolutely no resources running on this cluster in whatever namespace we have. However, there is something different that I have done from the cluster that Tom has deployed earlier today. And those are seen here through those 3 deployments. The 3 deployments that are running in the kube system namespace. How many of you are familiar with Kubernetes? A good amount here. So for those who are not very familiar with namespaces, it's a way of separating your containers or your pod, if we use the Kubernetes language. The kube system namespace is a separate environment where most of the things that run on the background would be, and they're like things you don't mess up with your application. The pods that are running here, the deployments that are running, to be more precise, are called HTTP application routing. The HTTP application routing is a feature that is connected to an Azure Kubernetes service, AKS, and that allows to expose a DNS entry for whatever service is going to run at that Kubernetes cluster. So it means that when you deploy a service on Kubernetes, it will have its own DNS entry, and you don't have to manage the entry within your DNS or get the load balancer IP and get all that plumbing done. It's done for you. Let me show you how I've enabled this and how we've deployed this with Terraform. So I'm using modules. You've seen it's a rather good practice for deploying resources with Terraform. And the value of it is not only it makes a simple view of a complex deployment. So in that case, I've created my Kubernetes module, which takes a bunch of parameters, including my service principal keys, the number of agents I want, their sizes. But at the same time, it's enabled this HTTP application routing. let me go to the HTTP application routing deployment. So the HTTP application routing is a feature that is not supported yet on the AKS resources with Terraform. So the way we do it, we use an ARM template to deploy this feature on the Kubernetes cluster. And for that, I'm using the Azure RM template deployment resource within Terraform. And Terraform is going to deploy the ARM template to Azure on the cluster I'm specifying. The only parameters I really need to pass here are the template body. And as you can see, it's pointing out to a JSON file. The JSON file here is nothing else than the ARM template I would be using if I was using to use ARM. And just to prove that I'm not lying here, this is the template I'm using. So you see, it has a schema and all the JSON verbiage, including, and I'm going all the way down to see my HTTP application routing parameter. So you would tell me, well, all of that for one parameter? Yes, because that feature is not yet, and I insist on the yet, on the AKS, or Azure Kubernetes Service resources in Terraform. It's something being worked on, and that's pretty much a workaround when the feature is not available in Terraform. You can fall back to ARM. However, when the resource is available natively on Terraform, we definitely recommend to use the native resource within Terraform to do that deployment. So it's really a trick in the temporary time when that resource is not available. And then you have the parameters. That's the ARM deployment. You pass the parameters that the ARM template would require. DNS name, service principal, VM size, and so on and so on. All right. Now, going back to my demo. Now I'm going to do one thing. I'm going to edit the Terraform definition file that will enable the deployment of the application per se on that Kubernetes cluster. So going back to my files. And since I'm very lazy and I don't like to write code in front of a large audience, I've already written the code. The good thing about that is you know your code is going to work. Well, hopefully. We'll see if that's true. Let me run that, and then we'll walk through the code in a minute. So I'm doing a Terraform apply. So as Tom mentioned, it's going to compare the existing state that I have on my machine or on any backend, could be Terraform Enterprise, for example, make that comparison, and say, OK, I'm going to add 4 resources on that Kubernetes cluster. You sure you want to do it? Yes, I want to deploy my app. So it shows all the output. The apply is complete. And now I'm going to walk with you through the code. So the first thing I wanted to mention here is I'm using the Kubernetes provider within Terraform to talk to AKS. But I'm not using the config file, the kube config file. It has all the secrets and allows us to do pretty much anything on the Kubernetes cluster. You don't necessarily want to have that file on any laptop or any environment. You want to keep that secure. The fact that we are using the module allows us to call the module output, especially the client certificate, the client key, and the certificate, which are technically within the kubeconfig file. But I'm not referring to the kubeconfig file. I'm just getting the provider to provide me, if I can allow that, the certificate, the key, and the CSRs. Then I define the app name. It's a variable you may want to use or reuse at different times. And then I'm using 2 modules. The one is the Kubernetes ingress. That one is actually deploying the ingress definition, which will talk to the HTTP application routing. So the HTTP application routing, in detail, is implementing an Nginx ingress controller on Kubernetes. And here I'm just defining how that ingress controller should behave. And finally, I'm deploying the app. So again, I've done a module for the app, and I'm going to look at the app itself. So as you can see, the modules, let me try to zoom.
Control, yeah.
There it is. So I have all my modules in the same directory. So they're local. Those are not shared on a Terraform Enterprise or in a public registry. They're local on my environment. And that's how you call them. So you call the voting app as part of a subdirectory of your definition. It's in the case I've done. And the way I do it, I define the Kubernetes resources like you define the Azure resources, same mechanism, and define the different parameters that are required. In the case of Kubernetes, replication controller requires labels, requires a selector, and the template of the container. So as you can see, I've hard-coded the image name. So in case you want to download as we do the talk, you can download the container on the public registry, nothing hidden. You pass the limits on the container that you want to use, and some environment variable, like the Redis cache. So I'm going to leverage the Redis cache that Tom has deployed earlier today within the initial Terraform deployment to store the data of that voting application. I'm not passing the password. The password comes as a variable for this module, but it's technically an output of the Redis module. So I'm passing the key secretly across the module without any storage on the disk. All right, so let's look at what's going on the ingress and the DNS entry. So that ingress controller that is talking to HTTP application routing, we can get the logs. We can see what's happening. And in this case, I can see that it has updated, I'm showing it on the top, a TXT record for the application named MS-build with a DNS zone which is pretty awkward. It's a GUID, and that GUID is specific to your cluster. So every time you deploy a cluster, you have a different GUID that is very specific to that environment. One of the scenarios that is enabled behind that is something that was announced at the keynote on Monday, dev spaces. I don't know if you remember a bit the dev space thing. So it allows you to have different namings or different entries in the DNS that have different version of your containers. So you have the production environment, and then you may have a test environment which has a different namespace. And those different namespaces appear on that DNS entry. So it's a way to connect the dots with what you have seen on Monday during the keynote. I'm just trying to connect the dots so you understand better some of the values that come with that. So that's for the DNS. And now I'm going to look at the logs of the ingress controller, Nginx ingress controller, at the speed of internet. And you see that yesterday night I had a test. It's over here. But you can see the logs. So whenever you have an HTTP client that hits the application, it will be logged on the Nginx ingress controller, and you can get the logs here and download those info in case you have or you need you need to troubleshoot your environment. Cool. You want to see if the application works?
Hang on. So before we do that, I think because this is a voting app, and I think that there is still like a huge audience here, so we should probably add some monitoring in there.
It's usually the best practice.
So at this point, if you want to add monitoring, how many of you are familiar with ARM templates? So almost the entire room, right? So one of the things that we've done is to also support Terraform at the heart of Azure to make Terraform a resource provider in Azure. So I don't know if like any of you looked at the talk today morning that Vlad and Brendan Burns gave around some of the ARM improvements. One of the things that we've done in ARM is to have a Terraform OSS resource provider. So what this gives you is the ability to take anything that you want to use outside the Azure boundary, using exactly the same resource provider that is written for Terraform, but now like sort of use the infrastructure as code that you're already familiar with ARM templates and be able to exercise that. So what that gives you is the ability to say, use something like Datadog or Cloudflare and so on directly from your ARM template JSON itself, right? So I'm going to demo some of what this looks like. So one of the things that you see here is a JSON file. One of the things that you can do now in Azure is this notion of a template, shared template. So what you can do is you can just have a JSON file that you created as a template and share it. You don't have to put it in GitHub. You can just provide it for others to use within your subscription or whatever scope that you want to provide here. So one of the things that I have here is a Datadog template. Let me first go and execute it. So just to show you, we have a Datadog dashboard that's going to monitor the Kubernetes cluster that we are using in this demo. And it's going to have the same voting app that Damien created is going to be monitored using this Datadog dashboard. So right now, we don't have anything specifically for what I want. So I'm going to go back and say, look at what this gives me. So let me just do the deployment first. So all I have here is an ARM template. I'll go through it in detail. But before that, all I'm specifying here is a resource group, an API key, an app key, so that I can register Datadog as a valid provider with Terraform within Azure, right? So now I have, and I'm going to create, I'm going to track the container image that Damien has deployed, and I'm going to have like a title for the dashboard that I'm creating called the Build Voting App Time Board from ARM. So let's just let's kick off this deployment. And while that's going on, let me show you what that template looks like. So what we have here is standard ARM. The only additional things that we want to look at here specifically is this new resource type called Microsoft.Terraform OSS/provider registrations. So what this does is, given the API key and app key that I just passed, you can basically provide a provider type. And this provider type, again, will map to a first-class Terraform provider. So one of those ET providers that you saw in Terraform, you can now go and reference them from this ARM template. And then what you do is, you basically say, OK, within that particular Terraform provider, I want to create a resource. So now you're not only basically registering with a Datadog instance that's outside the Azure boundary, but you're also going and saying, I want to create an instance, an actual resource within that Datadog instance that you just registered. So what that means is, now you can go and use the Datadog-specific syntax to create a new dashboard, like a time board in this case, and provide exactly what you need using the specifics of what the time board needs as parameters. So here you're using a bunch of graph queries, which is basically saying, I want to track the CPU usage, I want to track containers running, a whole bunch of metrics that I want to monitor on my Kubernetes cluster using Datadog from ARM, right? Let's see if it went and created it. So if everything goes well, hopefully it should show a new time board dashboard here. So there you go. So let me switch back to Damien while we exercise the dashboard. Yeah.
All right, so let's see if the app really works. So I've created a short URL based on the GUID that we have, so you don't have to type that super long DNS entry. And go to http or https column wak/ak.ms/tfk8. Oops, sorry, let me bring that on the board. I'm going to, so while you all connect and vote for the favorite value of that application, I hope no one is going to click reset. So we have a real value, a real representation of that room. I'm going to switch to my dashboard. So we have the detailed time board.
That's the one, yeah.
That's the one. Oops.
Oh, no, I think you didn't refresh, probably.
Sorry.
Refresh.
I need to refresh the list. There it is. So I'm showing CPU usage. A couple of things I wanted to highlight here is we're monitoring the CPU usage of the cluster itself. We're also having an info about the number of containers running in the kube namespace, kube system namespace, and then you have here the number of containers, let me zoom, associated in blue, the number of containers associated to my application, the Azure-vote-front. You can see it's spiking. So maybe what I'm going to do is also do something which is scale the number of nodes, or sorry, scale the number of pods that I have for this application so I can answer and support the load that is coming. So we're going to also use the Terraform provider for Kubernetes to deploy and to scale out the number of replicas that I have on my pod. So what I'm doing is I'm saying, by using the variable entry here, it's moving at the same time. So it really is playing with me today. So I'm specifying the number of replicas to this -var, which is overwriting a variable within Terraform. Knowing the state, you remember we have that state, so it says, oh, today you have 1 replica, I'm going to scale to 3. So let's approve that. And now I have 3 pods running for this voting app. We can see that in the Kubernetes dashboard. If I look for the pods, you can see I'm in the wrong namespace. No. Maybe I should refresh. Oh, that explains why. I think I lost my connection to the cluster. Yep. Let's reconnect the tunnel so we have the right info. Network can be tricky sometimes. You see the CPU usage? Wow, you've been impacting my nodes a bit. We have an F2, so that's pretty good. And I have the 3 pods running my MS build front demo with a memory breakout and a bunch of info that comes from Kubernetes directly. Datadog allows to do queries and more advanced entries. And you can see that through the kubectl command. That's pretty much it for my demo.
You want to show the visualizers, not?
Oh yeah, I forgot to do one thing I wanted to show you. So one thing that we have within the Terraform extension, let's do it in the UI, is the visualize. I'm going to run the command directly. It was not.
You missed an R there.
Oh, I missed an R. You see why I always have my demo scripted? We want it in PNG. Nope.
You're not outputting it. Oh, no.
Oh, that's okay. We can flip that. I think I have a screenshot of that.
Yeah. Anyway, oh, sorry. Yeah, I know why. Again, never write code in public. So the Terraform graph, which is the command I run here, is actually getting all the architecture of the provider and the different resources and map them into a nice graph. The graph can be exported as a PNG file, which is what I've done. And it shows me the global architecture of the application I've deployed. Where's my graph file?
It's right here.
It's there. And there we go. Let's make some real estate. So you can see all the dependencies of the different components and resources of the application that I have deployed. The nice thing here is that some resources can be deployed in parallel. because they have no dependencies. Some resources will wait on the other resource because they need the password of the Redis cache, for example. So if I'm deploying everything, I know, I'm confident that not only my Redis cache will be deployed correctly, but my application will wait until the cache is done and get the right password, the right entries, and everything. So this approach can combine multiple providers as well. Azure is one of them. You've seen multiple other clouds. And that dependency will understand the different resources on different clouds and create that nice layout of different resources.
Yeah, and just one other thing is it's interesting that even if I did like a load balancer, for example, and it would have like a really complex graph because it's abstracting, you can take all of this and make it into yet another module so that somebody else can now reuse it without needing to understand the underlying complexity of the dependencies that you care about. So now you have this really nice effect of high code reuse of infrastructure snippets that you can start sharing around. Flip back.
So very briefly, I want to review what we have just done. We had an AKS cluster with an Nginx ingress controller that is piloting the Azure DNS to have the HTTP application routing. Then we've deployed the app with an ingress, a service, and a replication controller that talks to the DNS that we have through the HTTP application routing property. And then we've scaled out the voting app so that if we have thousands of people or you have a Black Friday type of event in your country, then you can scale correctly.
Awesome. Thanks, Damien. So just to start wrapping up, I just wanted to give a sense for what are the different things that are happening around Terraform that's happening sort of right now as we speak and in the near future. One of the things that we're doing is really shifting focus completely into the provider to make sure that we have complete coverage for every resource that is required by most customers. We did show that there's an escape hatch of, say, using the ARM template, but with that you don't get some of the goodness of Terraform with, say, plan and making sort of this really quick build test loop. So we want to basically have native support in Terraform for everything, every single Azure resource. So one of the top asks from our customers was auto-scaling. Obviously, for a lot of these things, we show these in demos to scale, but obviously you want to auto-scale any Azure resource. And that's something that's available. We have the API for it, and we're working on the provider. So that's one of our number one things that are in progress. And then the next thing is MySQL and PostgreSQL. We already have the functionality in preview. So we don't just do things that are in GA. We already have the provider resource available to you in preview. But however, as it GAs, there are things that change. And we want to make sure that we sort of catch along and make sure that the pricing tiers and the simplicity of how you use it with Terraform doesn't distract and it doesn't break. So we have a very clean upgrade that we're trying, which will just happen with the migration path without worrying about preview to GA transition. Another thing is, especially for developers, they care about publishing from different repositories like GitHub from source or Bitbucket from packages onto app servers. So that's another thing that we're really focusing on. And this is where we're trying to look at, okay, the front end part of it as a developer, how would you go about publishing to app servers and making that a very intuitive experience within Terraform. So one of the things I want to talk about is, as these are just a tiny little sliver of features that we're working on, but I want to sort of show you, if you wanted to start influencing sort of what we do. By the way, space is one by narrow margin.
By one. Wow.
So let me quickly show you. So if you want to start influencing our backlog, I know all of you are using Terraform with Azure. The first question is, okay, how do you basically start influencing what we do? So everything we do is out in the open. So one of the things we have is this is the repository for the provider that we work on, and this is the central focus of all our requests and everything that we look at from a prioritization perspective. So I do encourage all of you, if you feel that, okay, this is missing or this is something something that I would like to have, to basically go ahead and create a new issue. Have a bug if it's something that doesn't work as expected, have a feature request. We take feature requests very seriously, primarily from the GitHub repository, the reactions to it, the comments on it, the activity around it. And that becomes like a very important part of how we prioritize features. And even if you have a question or a doubt about how to use Azure with Terraform, a lot of the documentation and guidance that we do is based on these. So think about the repository as the community, and please do comment to it and share. And one of the things that you would find here is also milestones. So you'll see what's going to happen, like what's currently in flight and what's going to come soon. So if you look at when is this particular resource coming in, then you can look at the milestones and you'll be able to get into the details of what's going on there. And if you really want to go into the dreary details of what we do day to day, even that's public. So our entire Kanban board, our sprint work. So we have nothing really like to hide. Everything we do is out here, so you can see our progress on a daily basis. And I'll also be adding some more stuff to the wiki for a higher level sort of roadmap and strategy and so on, just to get more feedback. So that gives you a quick run through everything here. One of the things from a tooling perspective, we are seeing Visual Studio Code being one of the primary editor for using Terraform. A lot of the contributions are from other major cloud providers across the lake and in the Bay Area into the Terraform extension. So the generic one, for example, is contributed by AWS and others. So one of the things we're trying to do is to figure out how to add more value from the Azure Terraform perspective. So one of the things we're going to have is the ability to do functional testing in Visual Studio Code. So what that will do is give you the ability to spin up these Azure container instances that will exercise your infrastructure as code, and then you'll be able to do an end-to-end, an actual test. Instead of just doing a sort of a mimic in the Cloud Shell, you can actually do what it's going to look like in production and build up a test environment right there. And that's coming very, very soon. The next thing is to say, okay, I have an Azure infrastructure, I'm learning Terraform, I want to understand how to quickly get going. How do I reverse engineer my existing Azure infrastructure to Terraform and then start tweaking? So that's something that we take very seriously. There are several community contributions around this and several ways to do this, but we want to make sure that the way that we choose is production ready and scalable. So we're going to take our time. We're not just going to give you a tool that works, but it's not like just there yet. And finally, we have a bunch of generators and yeomans and so on to help you with ordering resources and modules that will start showing up that you can start using right away. So these are some of the sort of progress that we are focusing on. And just to do a full recap, we started off talking about ordering with Azure Terraform extension in Visual Studio Code. And then we shifted gears, and Tom talked about how do you provision to Azure. So you can use Terraform open source, Terraform in the marketplace, as well as Terraform Enterprise for teams and for for governance and policy as code. And then you have, Damien went through how to deploy microservices to Kubernetes using Terraform. And I also kind of sneaked in the thing where you can actually deploy any third-party resource, such as Datadog, using the Terraform OSS resource provider, just using your own ARM templates as you do today. And finally, we had a quick view of what's next and how to engage. You don't have to worry about all these resources that we're showing you. I'm going to have every single thing that we showed you today in the ak.ms/tf link. And so if you go there, you'll see all the different, all the code that we saw. Every single link that I showed is all in there. So you don't have to worry about listing out a bunch of links. And please do email me, achandy@microsoft.com, with any questions you have around the Azure Terraform integration or any Azure OSS integration in general. And you can follow me in Twitter at rcrnmsft. And Damien is focused on the DevOps in the DevOps OS space as well, and he would be a valuable resource to ping on, and he's pretty deep as a subject matter expert in Terraform, as you just saw. And finally, Tom is the HashiCorp guru for everything Azure Terraform. So please, that's both his GitHub handle and his Twitter. So if you're in GitHub, he's going to be there, and you can start bugging him. Don't bug him too much, though. So finally, visit us at the HashiCorp booth. It's right near the Quiet Zone. And anything you want to know more about the HashiCorp-Microsoft partnership, we do not just Terraform, obviously. We do Vault, we do Packer, we do Console. And all this goodness will start showing up in this tiny URL here. And finally, before I go to Q&A, do complete an evaluation form for every session I attend, especially this session. And any questions? Yep.
Yep. How easy is it to reverse engineer like an Amazon VPC and use that reverse engineering generated on Azure?
Yeah, so the question is, how easy is it to reverse engineer, say, an Amazon VPC and use it in Azure from a Terraform context? So I'll start with just the basics, and then Tom might add something more advanced. But basically, think of it as modules in the registry are like a nice abstraction. So we're really not cloud agnostic. We're very cloud conscious, right? We're very provider specific. So what you would do is create a module that tries to basically create everything you want for a VPC. You'll use a VPC module in AWS. And then look at the comparative VNet module in Azure and try to build things at that layer that consumes that, rather than think about doing it at the resource provider layer. It gets messy. And Tom, do you have anything to add there?
Yeah, so I was going to say the nice difference between, or like one of the main benefits of Terraform is it gives you a unified DSL, but you can use the power of each cloud. So for instance, like in AWS, you may have a VPC containing a bunch of existing resources, and are you looking to migrate a bunch of existing resources across? So there are tools that let you do that, like to import state for existing resources into Terraform. Terraform doesn't have a translation tool between different APIs or between different clouds, because like an SSD on Azure isn't necessarily the same as on some of the other clouds. As Arun said, you can build out modules for this. That's one approach. But yeah, I mean, it depends on your specific scenario. If you're looking to import resources that you've already created on Azure, you can totally do that. There's a Terraform import command. But there's no migration between AWS or Azure or Google right now, or any of the others, because they vary different, or they're different. Yeah.
I'm new to Terraform, so this question about the resource provider.
Yeah.
That's a generic resource provider where you can submit any Terraform templates. I'm confused by that, and I'm writing a Terraform code which creates a VNet, which will have to go to the Azure resource provider, right?
Yep.
How do the two interact?
Yeah, so basically there's this notion of a provider. So the question is, there's this notion of a resource provider, and then we showed a bunch of Terraform files which have these things called resources. And then I talked about third-party providers like Datadog. So what is the taxonomy here? So basically think of the provider as something like the Azure RM provider is a provider that lets you take a bunch of, defines a bunch of resources. And each of the resources are things that you can natively use in Terraform. So let's say if you had a network or a VM, you can effectively go and create those things in the Terraform file using the resource keyword, right? But then there is also this notion of a provider, which is the high-level sort of thing for that entire cloud. So I have one Azure RM provider, I have another AWS provider, I have a Datadog provider. So that's just a collection of those things. And then we have modules that just compose these resources and or other modules and then build these higher-level abstractions. So these are sort of the three different sets of things that you can use with this. Tom, do you want to show that maybe? Yeah.
Yeah. Sorry, just to add to that. So Terraform supports a bunch of different providers. So Azure and like about 79 more. The difference between using Terraform on its own and Terraform with an ARM template, like Terraform with an ARM template is great if you're already using ARM templates. If you're already using Terraform, then like you can just use the Terraform resources. So it's a nice way of being able to interact with third-party resources from within an ARM template if you've already got like an investment or ARM templates that exist. But taking Datadog as an example, you can either do it within Terraform natively, like let's take a monitor for instance. Maybe that's a big example, but it works. Or you can do that with an ARM template. It depends what your investments are.
Sorry.
No.
So just a quick question. So when you did scale up the pods, right, it said you have one and you're going to three. Correct. Did you get the one from like actually looking there, or does it just know? Because what if I had to change that to 17 manually before that?
So yeah. Okay. So Terraform has a local cache in a state file, or it has a state file which is potentially local machine, potentially elsewhere. What Terraform does is download that file. Do a refresh, so it goes and checks Kubernetes to say, hey, you've scaled it from 1 to 3 anyway, and so there's nothing to do. So it'll refresh each resource when it'll recheck the values at the start. Yeah. So, okay.
So you were talking about function tests with Terraform and Azure. Are you imagining something like AWS spec where you're testing infrastructure, or server spec where you're going in and checking VMs?
Sorry.
Trying to see if the function test that you saying no
Yeah.
inbound all security.
I'll just repeat the question. I get what you're saying.
Yeah, repeat the question.
Yeah, the question is basically when you're doing a functional test in Terraform with Azure, are you going to be doing like the server-side infrastructure spec, or are you just doing like a client spec? So, Damien, do you have an
Yeah,
answer?
I can answer that. Been working on that functional spec for a while. So what we're going to do is we're going to take the module or the definition that you have. We're going to provision it on Azure, and then verify a certain set of assertions that you define in your test. So you're going to say what you want to verify to confirm that your module or your resources are correctly provisioned.
So it's a server spec, right?
Like AWS spec.
Yes, but
Yeah.
we're also we're doing things with Kitchen Terraform, so you can use Ruby, and we're also looking at other like things like Terra Test and so on.
Yeah. Okay.
Any other questions?
Hey.
Just to get one more. Go ahead.
Oh, go ahead.
I just had, does Terraform now natively supported in VSTS as far as part of the CI/CD pipeline?
That's an excellent question. So the question is Terraform supported in VSTS as part of the native release pipeline? So that's something that we're very interested in doing. That's again something where we do have a community extension for Terraform. However, we want to build something that's production ready and scalable. So we're looking to see whether we want to use that or we want to build our own. And we do have a blog that's coming out very, very soon that'll talk about how do you use VSTS with Terraform and Ansible and other tools. But that's just like current level guidance. Don't take that as sort of the production ready product thing, but there's guidance of how you can do it today. You can do it today, obviously, but for any using the Terraform extension. And then eventually we're going to have, and we do have it in the roadmap to have a first class native experience in VSTS.
Yeah, it's worth saying it's just a command line app. So in the meantime, there's the extension, or you can just run a command line and then switch the extension when it's available. But
Yep.
yeah.
Yep.
Hey.
Is there a timeline for Swagger Spark with the SDK to expedite features in Azure getting into Terraform?
Is there anything in particular you're looking for?
Yes, but not off the top of my head that I can.
So the question is there any way to expedite some things in the Azure resource provider for resources that are in Swagger, for example? Swagger is basically the auto REST API spec that Azure publishes, from which we use the Go SDK. Terraform is written in Go, and then we have the provider call from there. So as I said, the GitHub repository is your friend. So please do go to ak.ms/tfgit, submit a new resource as a feature request, and we look at reactions and we just do the fastest ones. But as I said, we're also doing a bunch of tooling that we're thinking about. How do we accelerate some of this? So that's something that we're working with Tom and others in HashiCorp to figure out. How do we accelerate this kind of coverage in different sort of ways? So that's another thing. And we're also going to help you with some boilerplate if you want to contribute as well. But in the meantime, if it is not supported, you know what to do. The things that Damien showed you, which is use the ARM template embedded in there. And Tom had an idea also of using modules with ARM template, maybe? That was another.
Potentially. In terms of getting stuff prioritized, if you thumbs up, like this one, for instance, so we sort, when we're looking for issues to do, we basically sort by thumbs up. So, like a new resource to attach a disk to a VM has
Is our number one.
13 thumbs up at the moment. So if you thumbs them up, when we sort, we'll see it at the top, and then we can work on it sooner. As I say, like if there's a GitHub issue for that, then thumbs up it. If there's not, please open one.
Yes.
Hey.
This is kind of a conceptual level. So Terraform's mainly targeted, I guess, at infrastructure in the cloud itself. But where do you draw the line as far as actually deploying the applications for deploying updates and other things like that? Would you suggest a different tool for that kind of thing?
So the question is, where do you draw the line? Like Terraform's a tool that spans many things, infrastructure and services and everything else. Where do you draw the line as a deployment tool? Terraform can do deployments. It's not necessarily what you'd want to do deployments with. It's great for setting up your infrastructure. So in like the example I showed you of putting a connection string in a secrets tool, and then having some external, like a CI system or in your case, like VSTS, doing your releases. Like Terraform can do that. It's not necessarily like, yeah, it depends on your situation.
I think the best thing about Terraform is that it's simple and it lets you do things like nicely in terms of building out infrastructure. And the reason for that simplicity is that it leaves it at the infrastructure layer. There are tools, as you know, that try to go all the way from bare metal to everything. It doesn't try to do too much, so it's perfect for the new sort of immutable world. And then there are really, Ansible is a nice tool, for example, beyond that, if you want to go and say, okay, I want to now do some in-guest configuration and so on. Or you would do things like, you want to be in the Kubernetes layer, you do what Damien was showing you, where you just deploy your app and not worry about what's underneath, and then have modules that abstract away, get someone who's a Terraform guy to build a module that abstracts away all that complexity for you. Right, so that's kind of the nice thing about it. And the provider model is intentionally not agnostic because you're getting the best of all worlds rather than saying I want to do the sort of least common denominator. Sorry, he had a question for a while.
So sorry, that's my second question.
Yeah.
You know, as someone who writes a lot of ARM templates, I'm looking at this session and thinking, maybe I should be writing some of these templates using Terraform. But I'm concerned about the previous question that these new resource providers, enhancements to resource providers in Azure are happening every day.
Yeah, I get that. This is a question I hear a lot. So basically the question is, we have ARM template, and I'm a person, he's someone who's writing ARM templates. How do you, like when we think about Terraform, I think about, oh, there may not be adequate coverage for Terraform. So that's why we're trying to build this balance where if you have ARM template, the native coverage that you get in Azure, and you're exclusively working in Azure, maybe you can use the ARM template. That is probably the right thing to do. But however, if you find that you want to use, you like the simplicity of Terraform, or you want to use things across providers, then you now have another option within ARM template where you can go and use the Terraform provider. So you're still in the ARM template world, but you're using third-party providers like Datadog from within Terraform. But then when it comes to someone who's actually looking at things purely from a multi-cloud lens and saying, I want to use things across providers, and that is my core focus, and that's what I'm going to do all the time, then it becomes important that you embrace something like Terraform, and it becomes like important to start embedding. Like if you find a resource missing, you do what Damien showed you and what of embedding ARM template in Terraform as and when needed, when there are gaps.
Yeah, it's worth saying we're adding stuff frequently. So as Arun said, like there's the ARM template resource you've seen demoed. Like we're releasing, this is this week's release. We've added a lot this year. It's kind of crazy scrolling by.
Yeah, if you're doing any core stuff, I think we're there. We're sort of in terms of like core IaaS, like the building blocks of Azure, most of that is already supported in Terraform. There are now this long tail of requirement that one customer wants to use some esoteric resource, another person wants to use yet another esoteric resource, is where there'll be a problem. But I think mainstream, if you want to get things done for the 80% of the scenarios, you should be able to do it right now.
Yeah.
It shouldn't be a problem.
No worries.
Sorry.
Yes. Kind of related to that, how for lowering existing IaaS resources, how do you guys match like the latest API?
So we had, let me repeat the question.
In general, like, I know there's API version of VM scale sets in private preview. It's going to get released at some point. Usually, how far behind?
So the question is, how do we deal with like new API versions, basically? So until recently, we've basically been going with stuff that's GA just because it's simpler. More recently, we've been adopting things that are in public preview. So application security groups are a good example. And there's a bunch of extensions, as you mentioned. Yeah, AKS. And as you mentioned, VM scale sets have a bunch of new stuff. We generally look to add it when it's in public preview, but it depends on demand. Like if it's something we know is going to be really popular, like AKS, Postgres, or MySQL, then we can do it when it's in beta. It depends on demand, basically.
I wasn't arguing.
No. No. It's it really depends on demand. If it's in the Go SDK, and if users can opt into it, then it's probably fine to add.
Is there any plans to create any boilerplates or templates for contribution, like different contributors?
So the question is there any plans to create boilerplate templates and contribution guidelines? I mean, definitely. I mean, we're going to start adding contribution guidelines. You'll see that as part of the repository. And we do have a Yeoman generator. You can search for modules, for example, along with how do you do testing with Kitchen Terraform. But we want to start, these are all mostly community contributions. So I think the best place to start would be looking at the Azure Terraform extension in VS Code. And we're going to slowly start adding a lot more links to a different set of boilerplate that you can generate from there. And then I think Tom is looking at the generic, how do you contribute?
Yeah, so I was going to say, we've added a bunch of stuff to the Terraform website recently for how do you contribute. Like, so for instance, a Terraform resource has a schema, like going internally. There's a bunch of instructions here on like what the schema is, what the data types are, when you'd want to choose X over Y, and like basically how you can write that resource. Yeah, as Arun said,
and we love contributors, and that's our goal, is to really like throw out the red carpet for contributors. And another thing for that is we also sort of start prioritizing requests that contributors do, because they're sort of shaping the community along with us. So we don't just look at the reactions, we also look at have you actually contributed. Then your GitHub handle is obviously far more respected as compared to someone who's just voting for the heck of it, right? So I think contributions can happen in two ways. If you know Terraform, contribute modules to the registry. Terraform is a beautiful, simple language. And module contributions, we have Yeoman generators for that, and some boilerplate for that as well. And then if you're looking to do Terraform provider and you're a Go developer, then you can email me and we'll definitely start, we'll prioritize external PRs. We prioritize external PRs quite a lot and guide you through it, and Tom is going to review it and say what's wrong, what's right. So the best way to learn is sort of do a PR around the modules. Awesome.
Any other questions?
I think we're out of time, but yeah, you can come here if you want to have any questions.
Thomas, last question. Any papers or guidelines on if I want to write a multi-cloud mindset? Anything that as Tom said, you're not translating it. You need to think about different providers. Any guidance? I'm starting a new project, and it is based on Kubernetes. I may end up with multiple providers. Any guidance that I should keep in mind as I'm ordering my Terraform?
So basically the question is there any best practice guidance around as you start ordering Terraform files? Tom, is there?
Yeah, there is on the Terraform website. There's also a bunch of guides we have on here around like multi-cloud in general on the HashiCorp website. But yeah, I mean, if you go to guides, Terraform recommended practices, there's suggestions here. How you use specific resources in specific clouds we don't cover, because I mean it's specific to each cloud, and we'd be here all day.
But for specific clouds, like for Azure, we're building out solution architectures and modules and things in the registry that will help you look at existing code, and you can look at the provider code. So there's a lot of existing code, so it's pretty easy to get started, because now we're in a reasonably mature, advanced phase in this project in terms of integration. So it's not like you have to start from scratch. You have a lot of code out there that already exists.
Cool. Right. If there's anything else, feel free to swing by the booth, and we're all around. So,
thank you.
Thank you.